NASA's latest moon discovery is not routine. Scientists are expressing serious concern about findings that could change everything we know about our celestial neighbor. Recent analyses of lunar data, particularly in the context of upcoming Artemis missions, have revealed several anomalies raising eyebrows among experts. A groundbreaking 2024 study published in Nature Astronomy, led by Thomas Waters of the Smithsonian Institution and a NASA Jet Propulsion Laboratory team, re-examined data from the Apollo passive seismic experiment stations deployed between 1969 and 1977. They uncovered over 200 shallow moonquakes originating from depths less than 30 kilometers, with magnitudes reaching up to 5.5, far more significant than previously thought. These quakes are linked to thrust fault scarps near the lunar south pole, visible in lunar reconnaissance orbiter imagery, as lobate scarps measuring 10 to 30 meters high, 5 to 10 kilometers wide, and extending hundreds of kilometers. Gravitational irregularities mapped by NASA's Grail mission from 2011 to 2012 show mass concentrations, or mascons, under impact basins like Imbrium, creating gravity highs of plus 300 milligauss. Compositional oddities, such as elevated sulfur levels at 0.3 to 0.5% and hydrogen indicating water ice, confirmed by Chandrayaan-3's Vikram lander in 2023, add to the puzzle. Magnetic anomalies up to 100 to 300 nanotesla detected by Lunar Prospector in 1998 and Kaguya in 2007 suggest remnants of an ancient dynamo that ended 4.1 billion years ago, with rusty ilmenite-rich regions high in titanium over 10%, hinting at past water interactions. Thermal swings mapped by LRO's Diviner instrument from 100 Kelvin to 400 Kelvin daily, and ShadowCam's discovery of illuminated pits and caves like the 100-meter deep, 45-meter wide pit in Mare Tranquillitatis point to potential lava tubes for habitats. These findings do not align with existing models of lunar geology, which assumed stability after 4.5 billion years of formation, Mare volcanism ending about 1 billion years ago, and major basin impacts like the 2,500-kilometer South Pole Aitken. This comes at a pivotal moment as NASA prepares for human return via Artemis. The moon plays a crucial role in stabilizing Earth's rotation and tides, making it central to NASA's Artemis program and future human missions. By maintaining Earth's axial tilt at a precise 23.5 degrees, the moon prevents extreme wobbles that could range from 0 to 85 degrees over millions of years, avoiding catastrophic climate shifts that would render much of the planet uninhabitable. Its gravitational pull, from an average distance of 384,400 kilometers, generates ocean tides with bulges up to 1 meter high, influencing global currents, ecosystems, and even weather patterns. Without the moon, Earth's day length and seasons would be chaotic. NASA's Artemis program aims to leverage this vital neighbor, with Artemis I completing a successful uncrewed test flight in 2022, Artemis 2 scheduled for a crewed lunar orbit in April 2025, and Artemis 3 targeting a historic landing in 2026 at the South Pole, the first woman and next man on the moon. This site was chosen for its permanently shadowed regions holding up to 100 billion tons of water ice, essential for in-situ resource utilization to produce drinking water, oxygen, and hydrogen-oxygen propellant for sustainable bases and missions to Mars and beyond. International partners including ESA, JAXA, CSA, and commercial entities like SpaceX with its Starship human landing system are involved. Previously, lunar geology was considered settled, formed 4.5 billion years ago through accretion and giant impacts, with volcanic mare flooding ceasing around 1 billion years ago, and the massive South Pole Aitken Basin spanning 2,500 kilometers as a key feature. The orbital footage you're seeing highlights these intricate details, with craters, regolith, and glowing paths underscoring the moon's dynamic relationship with Earth. Yet, these new anomalies are prompting a re-evaluation of that stability, especially as we plan long-term habitation. Unexpected lunar anomalies, including unusual seismic activity and gravitational irregularities, challenge existing models of lunar geology. The diagram illustrates the moon's internal structure, with highlighted zones for seismic hotspots and gravitational variances against a cosmic indigo blue backdrop. Starting with seismic activity. The 2024 Nature Astronomy study reprocessed Apollo PSE data from 4 stations, identifying over 200 shallow moonquakes at depths under 30 kilometers and magnitudes up to 5.5, originating from thrust faults. These correlate precisely with LRO images of lobate scarps at the South Pole, features 10 to 30 meters high, 5 to 10 kilometers wide, stretching hundreds of kilometers. Unlike deep-focused moonquakes at 700 to 1,200 kilometers depth around magnitude 5, these shallow events pose direct threats to surface operations, driven by ongoing tidal stresses from Earth's pull and the Moon's core cooling, causing global contraction of 100 to 150 meters in radius over 4.35 billion years. Gravitational irregularities from Grail's twin probes, ebb and flow, mapped the gravity field at 20-kilometer resolution, uncovering mascons, mass concentrations beneath basins like Imbrium that spike gravity by plus 300 milligauss. Spacecraft in 50-kilometer low lunar orbit face variations twice as intense as Earth's, leading to orbital instability for prolonged missions. LRO follow-ups confirmed linear anomalies over mare basalt intrusions. These features disrupt uniform models of lunar evolution. Complementing this, magnetic anomalies up to 100 to 300 nanotesla from Lunar Prospector and Kaguya indicate a defunct ancient dynamo, with Chandrayaan 1M3 data revealing iron oxides and titanium-rich ilmenite areas suggesting historical water presence. Thermal data from LRO Diviner shows extreme swings from 100 Kelvin or negative 173 degrees Celsius to 400 Kelvin or 127 degrees Celsius, while ShadowCam on Danuri spotted potential lava tube entrances like the Mare Tranquillitatis Pit, 100 meters deep and 45 meters wide. Compositional surprises include Chandrayaan-3's detection of sulfur at 0.3 to 0.5% and hydrogen signatures for water ice in polar shadowed craters. What exactly did scientists find, and why does it matter now more than ever for future space exploration? These anomalies challenge long-held uniform contraction models, with active faults directly threatening proposed Artemis base camps, such as Nobile Crater. Simulations indicate magnitude 5.4 moonquakes could generate ground shaking of 1 to 2 centimeters per second, enough to damage habitats and equipment. Gravitational mascons complicate precise landings, as seen in Apollo-era errors of 2 to 10 kilometers, demanding advanced navigation for South Pole sites. Compositional oddities, like lower iron and far-side basalts and unexpected sulfur, question core formation theories and impact in situ resource utilization for extracting propellant from ice. While direct tidal effects on Earth remain minimal, subtle long-term lunar changes could influence our planet's stability. This reshapes mission planning. Lunar bases will require reinforced structures, and caves offer radiation shielding, but risks seismic instability. It influences Mars exploration by highlighting similar regolith and gravity challenges, and broadens planetary science to consider active tectonics on other moons. Ongoing data analysis by NASA and partners continues, with upcoming missions including Prime, one in 2024 for volatiles, Viper rover in 2025 mapping South Pole terrain, Lunar Trailblazer in 2025 hunting water, Artemis 2 in April 2025 for crewed orbit, Artemis 3 landing in 2026, and China's Chang'e 7 and 8 from 2026 to 2028. International collaboration via ESA, JAXA, ISRO, and NASA's CLPS landers will deploy new seismometers to study faults. Discoveries like this remind us how much of the universe is still waiting to be understood. If you enjoy staying ahead of groundbreaking space news and exploring the mysteries beyond Earth, this is just the beginning. Share this video with fellow space enthusiasts, and make sure to subscribe to Cosmic Chronicles for weekly deep dives into space, science, and the future of human exploration. The universe is vast, mysterious, and constantly evolving. And here at Cosmic Chronicles, we explore it together.